I will also create the OTP for you. Machine learning is important for IoT, and it is enabling a large number of data to be processed using a machine learning algorithm. So machine learning is an enabling technology for many IoT applications, as we discussed in the last classes. So machine learning is a technology which enables computers to learn from data. Is a technology which enables computers to learn from data and improve performance accuracy over time. So what do I mean by performance? So the performance of a certain application over time. So once we talk about IoT applications, we have large volumes of data getting collected. We have large volumes of data getting collected. So this is actually a good feature because machine learning requires a lot of data to make predictions. So the machine learning predictions become more accurate with the existence of large amounts of data. With the availability of large volumes of data. So therefore, the machine learning concept is very like suitable for IoT applications. Right? So since IoT requires, since the IoT generates large volumes of data, those data can be used. It can thus be used. The volumes of data can be used. They can be used. They can be used for training, validating, and testing machine learning models. Okay, so in the validating phase, what we are trying to do is we are trying to find the best fit model. I will discuss about that later. So we are trying to find the best fit model that matches with the data. So specifically with the training, in the training phase, we are going to train the machine learning algorithm to behave in a certain way. So under the validating phase, we are trying to improve it further. We are trying to improve the model that we obtain from the training phase uh, further and find the best fit model that fits with the uh, fit with the um, extreme cases, worst case scenarios, and will function accurately in almost any scenario. And then we have the testing phase. The testing phase is the phase where we add new data as inputs to the model that we trained, the machine learning model we trained, and then we test the output. We check the output for the new data. So in the testing phase, we can observe the actual performance of the machine learning model. So the IoT systems which generate large volumes of data can be used for training, validating, and testing of machine learning models. Apart from that, the machine learning technique can be divided into basically three types. Machine learning can be divided mainly into three types. The three types are supervised learning, unsupervised learning, and reinforcement learning. So the features of these types of machine learning algorithms are, in the supervised learning method, we are using labeled data as inputs. So in the supervised learning, we have inputs which are labeled. That means we have input and output previously defined. So in here, actually, in supervised learning, we are having uh, uh, data which we input to the system, and we give some expected output data also to the system. So what I mean is that in supervised learning, we have, for example, scenarios where we input like images, for example, with a certain picture, let's say. So let's say we are inputting a picture of a flower, let's say. So we are giving a picture of a flower and we are telling the system that this represents a flower. So each image that we input to the system will be labeled. And we are giving an image and we are labeling that image as a flower. And we are giving a tree. If we are giving a tree as an image to the system, we give the label of the image as tree. So the machine or the computer that runs this machine learning algorithm, the machine learning algorithm will know that this picture represents a tree, and this picture represents a flower. So the machine learning algorithm will learn with time what each image represents. So with that knowledge, when we input another like image of a flower or a tree, then the machine learning algorithm will identify that as either a tree or a flower. So if we give a new image of a tree, a new image, then the machine learning algorithm will tell that it is a tree. So basically, in supervised learning, we are giving data to the machine learning algorithm as labeled data. We are giving data to the machine learning algorithm as labeled data. So we give, some data where we label that data with a certain information. We give information regarding that data. So in supervised learning, we are actually providing a lot of information to the machine learning algorithm. And therefore, the machine learning algorithm can detect the object or some kind of a uh, feature or some kind of input using the previously provided data set. So for IoT applications also, if we depending on the application, we can use a supervised learning. So we need to check whether we can use the machine learning algorithm, and only then we can actually use that algorithm in our IoT systems. So this supervised learning method is good for cases where we have labeled data with labels. So if we have data with unlabels or with are not labeled, data which are not labeled, then we use unsupervised learning method to do some machine learning based predictions. So if we have unlabeled data, then we have data where we do not know what it means. So we have data regarding for example, we have data regarding the location of a certain device. Okay, so the location data of some devices we might have, but we don't know whether that location is we don't have any other data that says okay, this location is the location correct or wrong, some judgment. We do not have any knowledge to make judgments regarding the data. We don't have any data to make judgments about the unlabeled data. The machine learning algorithm do not have any idea about the single data that it has received. However, the machine learning algorithm can make decisions about the collective data, the entire data set that it has. So in this case, like if we have data regarding the locations of multiple devices, and we have locations, some other data, we have location data of devices which are in another location, then using unsupervised learning, we can say, okay, these devices are in this region 1. So other devices which are located further away are in region number 2. We can make such kind of conclusions about the overall data set using unsupervised learning. We cannot make decisions regarding each and every data point, but collective conclusions we can make regarding the data points. So if there are some clustering in the data sets, inside the data set, we can identify the clusters. using unsupervised learning. So we can identify clustering, we can do classification using unsupervised learning. Okay, so this also can be applied in IoT scenarios where we need to find out whether there are any clusters of devices in a certain location, or whether there are clusters of uh, data points related to some measurements, or something like that. Okay, so if we want to observe some kind of a pattern, shown by the data, then if the data is showing some significant pattern, then we can identify using the techniques of unsupervised learning. Okay, so basically that is also some technique that can be used for IoT applications. So then when we talk about the reinforcement learning, the reinforcement learning is, I think, important in situations and can be important for IoT applications. So reinforcement learning means reinforcement learning is a learning method where we make decisions based on real time data, real time updates. We make decisions based on real time updates. So reinforcement learning is usually used in cases where we need to take actions based on the real-time updates. So if we take, for example, a scenario where we have the access point, and now let's say this is an industrial scenario where we have a certain, router, where the router is connected to multiple robots in the industrial environment. So let's say these robots are moving autonomously in the industrial environment. So these let's say these robots are connected using wireless links to this wireless, to this router. So if the robots are trained using reinforcement learning, then the robots learn the path of moving. Okay, let's say these are robots. So these robots have to move along a certain path in the environment, right? However, like the environment might change over the time. So the obstacles that are there in the environment can change over the time. So although we train our robot to move along a certain path, however, if there are some changes in the path, if there are some sudden changes in the path, where a certain human, for example, is coming and sitting or standing in the middle of the path, then the robot needs to observe that situation and take decisions in real time uh, to change its direction or change its path based on the data. So after it reaches the point where it senses the, um, I mean, the senses the presence of this human, the robots need to make a decision here whether it needs to move forward or whether it needs to change the path. So once it makes a correct decision, it will move in another alternative path set earlier, that it knows earlier, or else it finds in this real time, and then it will avoid the obstacle in real time. So in autonomous robot systems, where we have like challenging environments, with changing obstacles, the reinforcement learning will be helpful to make decisions in real time. So we can make real time decisions using reinforcement learning. So based on the changes in the data, changes in the environment, based on the changes in the environment, the robots will change their decisions. So, there are many like mathematical models and mathematical functions that are defined to uh, defined to uh, 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 to uh, to implement this machine learning reinforcement learning technique. So in reinforcement learning technique, basically there is some kind of a parameter called the, I mean, function called the reward function. So based on this reward function, the decision will be made. So the reward function is defined based on the uh, based on the expected output from from the network, and the reward is getting higher if the decision that we make is more favorable for us in the environment. So anyway, so these are like in-depth knowledge or in-depth techniques that are used in reinforcement learning. So if you're interested, you can learn about reinforcement learning. So currently reinforcement learning is a emerging trend in not only in IoT but also in other sectors of machine learning related research and in implementations. So people are trying to implement reinforcement learning in their systems. So the reinforcement learning makes the systems make real-time decisions and make real-time updates regarding the environment. Okay, so those are the basic techniques that are basically used in machine learning. So so in IoT applications, basically we need machine learning for applications where we need to basically predict the future outputs. Okay, so machine learning for IoT can be used in many applications. We can categorize them into basically 3 or 4 applications, or 3 or 4 like um, I mean applications. So I will discuss about those. Right, so machine learning applications in IoT will be, right, so example applications where we can use machine learning and IoT, right? So I will rephrase applications where we can use machine learning and IoT, where we can use machine learning and IoT. Um, do we need to master programming languages in order to work with machine learning and AI? That is a good question. Now, programming languages, right? So programming languages are required up to some extent, to implement machine learning algorithms. However, like you don't have to be a very expert in programming. Okay, up to some level you need programming languages, but mostly like not only programming knowledge, you need the knowledge of probability, uh, mathematics, mathematics, statistics. You require a combination of all these skills. So programming knowledge can be just medium. It's okay that you are not a expert, you can learn, you can use very simple programming languages to implement the machine learning algorithms. So when we talk about the programming languages, basically Python can be used, and it's widely used for uh, training machine learning models. So you can use available, I mean, available libraries, uh, which are uh, libraries like Panda, I mean, NumPy. So these are libraries of Python, okay? And also scikit. I don't know whether I'm writing it correctly. Scikit. The scikit library is very popular. Uh, and this is the kind of basic library you can use to implement machine learning algorithms. So these libraries are available in the websites. So if you just type scikit library, you will get the links in the Google. So search in Google about scikit library, and you will get the links in the Google. So so you need to just go through the codes that are provided in these websites, and the meaning, or the idea of that code is also presented in the websites. You just need to copy paste it on your own notebook. You can use your own, I mean, notebook, we call this. So this is uh, like a platform online platform, which is available with the internet. Okay, so this is running, the Jupyter notebook is available online, so you can copy paste onto the Jupyter notebook, and you can provide the necessary data sets, and you can implement your machine learning algorithm in that platform. So you don't need to do a lot of software development, application development. You need a data set, and you need the machine learning algorithm, and machine learning algorithm uh, is already available for some applications, such as image recognition, image detection, and so on. However, if you want to have your own custom machine learning algorithm, you need to define parameters. You need to define uh, parameters that are specific to that algorithm. So there will be certain specific parameters that you need to define. By setting up the parameters, you can initiate the machine learning algorithm. So initially, the machine learning algorithm might not function correctly because the parameters that you define is not correct, right? So initially you define some parameters, but the output of the machine learning algorithm might not be perfect. So in that case, you need to keep on refining and updating the parameters until you get very accurate results from your prediction. Okay, so that is basically, I mean, regarding the implementation of machine learning algorithms in on your own. Okay, so basically, like once we talk about the machine learning applications in IoT, basically we have scenarios where we can use machine learning. So for IoT applications, basically we can use machine learning, right? IoT and machine learning can be used in applications where we want predictions, right? So predictive maintenance. So in IoT applications where we need maintenance over, like where we need maintenance, okay, where we need some regular maintenance, or like dynamic, or like some maintenance uh, uh, of the IoT network components. then we can predict the time at which we need to do the maintenance using machine learning. And next, anomaly detection and fault prediction. Anomaly detection and fault prediction. Anomaly detection and fault prediction. Okay, so if anomaly means like unexpected outputs, unexpected behaviors. So if we have in our IoT applications, for example, in the industrial IoT applications, if we see that some production lines are behaving unusually in an unusual manner, then we say there's an anomaly. Then the machine learning algorithm can detect the anomaly situation and can detect and predict such kind of situations. So along with the data it has the ability to predict the occurrence of an anomaly. Also it has the ability to detect it, but most importantly it has the ability to predict further anomalies occurring in the system. Also it can also predict the faults occurring in the system. And then we have environmental monitoring and control. Environmental monitoring and control. So environmental monitoring means like you can observe the data in the environment by taking measurements, and based on the measurements you can predict some output, or you can predict that something is going to happen. So based on that you can control the environment. You can take decisions to control the environment, and then by that you can achieve your goals. So what I mean is that, for example, let's say if you consider an urban scenario where we have like smoke or vehicle smoke pollution, then the artificial intelligence and machine learning algorithm is able to monitor like uh, the smoke levels in the environment, and if it goes beyond a certain threshold it can like inform the certain authorities in the environmental section, or else it also can give notifications to the people in the environment saying that this environment is now it is not good and it is polluted. So we can give notifications to the people, so the machine learning algorithm can take care of those actions. Then another application that might use the machine learning and where we use IoT is where we use smart energy management. So these are some examples only, but you can come up with other examples where we use machine learning in IoT. So smart energy management means like in situations where we have multiple energy sources. We might have energy sources from multiple energy generations. So we might have solar energy, we might have hydro hydropower energy, and then we have the coal power energy. So the machine learning algorithm is able to detect which type of power to use at a certain time instance uh, to feed the power lines, or distribute uh, to use in the distribution systems, power distribution systems. So sometimes we can manually do that using certain algorithms, but the machine learning algorithm can predict what energy will be available in the future and what energy will not be available in the future. Likewise, it can make some predictions regarding the future. based on that prediction, it will decide what energy is best to be used at the current moment, right? So likewise, machine learning has many aspects and has been shown to show um, more accuracy than other kind of mathematical programming or mathematical programs or other kind of fixed programs that we have set before. The reason is that the machine learning is always updating its decision based on the new data it receives. So it is all the machine learning plus IoT is also important in healthcare and remote monitoring healthcare systems. Okay, so in remote monitoring and healthcare systems, we require machine learning techniques to make good decisions regarding the healthcare services and make some useful outputs. So these domains are still practicing these machine learning techniques. So still it's in the in the research level. However, I think this is also going to be a demanding topic. So machine learning based IoT can be used for smart cities as well. Uh, and for it can also be used in transportation and logistics. Right? So machine learning can be used in multiple applications. So currently, so when we take specifically IoT, we can use machine learning in most of the IoT applications. However, IoT based or I mean machine learning algorithms in general has their own risks and challenges. So there are some risks and challenges when once we try to utilize machine learning. So one challenge that I would like to point out is the challenge of managing large volumes of data. Managing large volumes of data. Managing large volumes of data. So I mentioned to you that large volumes of data are favorable for machine learning algorithms because once we have more data, we can make more accurate predictions. More data means more accurate predictions. But however, once the data is above a certain level, then the system faces challenges in controlling the data. So the system has challenges controlling the data. Right? The system also has certain limitations in resources. So system faces challenges in controlling the data. Okay, so controlling, managing of the data is a challenge. Okay, so the controlling or managing the data is a challenge. Apart from that, uh, the there are other challenges that we have. So the scalability is a challenge. Scalability is a challenge. So scalability is a challenge. The reason is that scalability is referring to the situation where we are adding more devices into the system, right? Scalability means we are adding more devices into the system, adding more components into the system. Once we add more and more components into the system, the machine learning algorithm also gets complex. ML algorithm gets complex, and therefore sometimes it's difficult to get updates from our machine learning algorithm uh, with efficiency. That means sometimes there could be a delay. So that is the next problem. So real-time processing is going to be a challenge. Real-time processing is going to be challenge. So that means like the the machine learning algorithm will have a high delay in producing an output. Right. So it will have a high delay in producing an output. Apart from that, we have challenges such as security and privacy. Right. We have challenges related to security and privacy. Security and privacy. Okay, so the security and privacy of a machine learning based an application needs to be maintained. So that is also a challenge because we are working with large volumes of data. So providing security to the large volumes of data is a challenge. So providing security to large volumes of data is a challenge. Okay, so the fifth problem is model explainability. Model explainability. Okay, that is also a challenge. So model explainability is the situation where we cannot explain the machine learning model. Right, the machine learning will give some accurate results to our data, but we cannot explain why the machine learning algorithm has been defined in that specific manner. So let's say we have a neural network. Okay, so the machine learning can also be, implemented using neural networks. Okay, so machine learning actually, we call that deep learning, right? So machine learning, there are other categorizations that we can do. Uh, the machine learning techniques or artificial intelligence techniques. So I did not mention that in this lesson so far. So so deep learning is another learning technique that falls under artificial intelligence. So artificial intelligence is the biggest set that considers the learning that a certain other device can uh, uh, artificial intelligence means a certain device can learn about the behavior of the humans and the behavior of the environment using data. So basically, based on data, the learning that we do, we call as the artificial intelligence. Artificial intelligence is a broad concept, and it is concept that we are still trying to achieve. So artificial intelligence is the level so the artificial intelligence is a technology that we are trying to achieve, and that technology is focusing on creating systems or machines that creating machines and systems that functions on their own that function on their own that function on their own function on their own based on the data that they have based on the data that they have. So it is it is it is very essential in this situation that we teach these machines to function in the most optimal manner. So we need to teach the machines what is the optimal method to function at a certain situation. So AI is based on doing that. So it is a broad concept where we talk about teaching any type of a system or device uh, or some kind of robot to functions automatically on their own. Inside this artificial intelligence domain, we have many other categories where we call as machine learning. So part of the machine learning also can be, as I understand, there are some more deep techniques such as deep learning. So in deep learning concept, we use more complex algorithms than the standard machine learning to make decisions using the data. So in the deep learning, we use something called neural networks. So in neural networks, we make decisions based on the parameters that we set in the neural network. So these parameters uh, we define using trial and error method most of the time. So because of this, we do not know whether these parameters are actually accurate or not. We do not know whether they are accurate or not. Like if we just do the parameter determination, if we just determine the parameters using trial and error without using that method, if we are able to define these parameters using some logical reason, then we can explain our machine learning model. If we don't know how we set these parameters, then we do not know how to explain the machine learning algorithms. So so that is what I mean as model explainability. So the model explainability is difficult once we do not know how we set the uh, how we set the parameters. So when we do not have a specific method to define the parameters, then we call that model is not explainable. So we do not have a specific method to determine the parameters. So those are the basic challenges that we can observe in machine learning based systems. So basically with IoT and machine learning systems. So there are like many systems that are currently using machine learning, and in order to face these challenges, we need to follow best practices once we are using machine learning. So so such kind of practices uh, include uh, several actions that we can take. So we can create our data set using a representative. We can create our data set using representative data. That means like representative data. Okay, so we can create the data set using representative data. So what I mean by that is that we can represent the whole system. We can represent the whole system using the data that we collect. Represent the whole system using the data we collect. Okay, so what I mean is that we can represent the whole system using the data we collect. So whole system means like the system with all the worst case scenarios and unexpected scenarios. Right. So worst case and unexpected scenarios can be uh, can also should also be considered when we consider the whole system behavior, right? The whole system behavior must be taken into consideration once we are taking the data. So we can't only consider the data that we have collected when the system is under normal behavior. We also need to take the system behavior once it is behaving in an unusual or worst case manner. So we need to collect all that data. Only using all that data we need to train our model. And then we need to select the appropriate algorithms. We need to select the appropriate machine learning algorithms to train our data. So there could be different machine learning algorithms, but we need to select the most suitable one depending on our application. And then we need to do our testing of our machine learning model using real world scenarios. So we need to do real world testing of our machine learning algorithms. So we need to put our machine learning algorithm into the real world, and then we need to test its output. And then we need to optimize the solutions. So if we get some inaccurate solutions or unsatisfactory solutions, we need to optimize the solutions that we obtain. Okay. And then we have future trends, right? The future trends that we have with machine learning uh, are basically like when we talk about IoT applications, there are future trends or trends that we can observe happening in the world. So future trends happening in the world currently with regard to machine learning and IoT are using machine learning in edge computing, right? Using edge computing and machine learning, right? Also we call as edge computing and artificial intelligence. We call this as edge AI. Then we have federated learning. So federated learning means using machine learning at the device level, at the device level machine learning, right? We are training the device. So training the device can be done using a machine learning algorithm. And then we have explainable AI. Explainable AI. Explainable AI means like this is of course a general application where we use where we try to explain the AI method that we are using. We try to explain the AI model. So AI model. So if we use it in IoT applications, we need to be able to justify the AI model that we have used and its parameters. Okay. So with that, I will end the section regarding machine learning and IoT. So do you have any questions?